in this video we will discuss the problem find the safe position. The problem says that there are n people standing in a circle. The people are numbered from 1 to n and they are standing in the clockwise direction in form of a circle. They are waiting to be executed. That is basically they are waiting to be killed. And the counting begins from point 1. So the counting starts from 1 and proceeds across the circle. It proceeds around the circle in the clockwise direction. In each step, a certain number of people are skipped and the next person is executed, that is killed. So the elimination process around the circle proceeds until only one person is left and the last person is given freedom. So the last person that is left, the last person is not killed. So we have been given the total number of people as n and we have been given a value k, that is a number k, which indicates that k minus 1 people will be skipped and the kth person will be executed in the circle. The task is to choose a place in this circle initially that will be safe, that will survive in the end. So let's quickly discuss this with the help of sample test cases. So suppose we have been given n is equal to 5 and we have been given k is equal to 2. So in this case, every 2th person, every second person will try to kill. So let's quickly write the people. So let's say 1 is there, 2 is there, then we have 3, then we have 4, then we have 5. You can observe that all of them are standing in a circle in a clockwise direction. After this, what we'll do is we'll start from the position 1 and we'll kill every kth person. Like like the problem says that we'll skip k minus 1 people and we'll kill every kth person here. So basically what will happen now is, if I'll observe, so if I'm starting from here, so the second person I have to kill. So if I'm at 1, so this is the first person, then the second person is 2. So I'll kill 2. After that, what will happen? I'll stand at 3 because 2 is now killed. I'll stand at 3. When I'm standing at 3, so now again I'll kill every 2th person. So the 3 is the first person, the second person is nothing but 4. So I'll kill 4. After that, I'll stand at 5 because I've killed 4. Now I'll stand at 5. So when I'm standing at 5, again I'll kill the second person. So first person is 5, the second person is 1, right? So I'll kill 1. After this, what will happen? After killing 1, now I'll stand at 2. Like now I'll stand at 3. Now since I'm standing at 3, so I can see that I'll kill the second person. So 3 is the first person, then the second person now is 5. So I'll kill 5. After this, we can observe that only one person is left. That is nothing but 3. So I can return 3 here. That okay, 3 is the safe position here. Right. Let's discuss another sample test cases. Suppose that we have been given n is equal to 3 and we have been given k is equal to 2. Now in this case, we have 3 people. So 1 is there, 2 is there, 3 is there. These people are standing in a circle. Now what will happen? I'll start from 1 and then I'll kill every 2th person here as well because k is equal to 2. So every second person I'm going to kill. So what will happen? First of all, I'll kill 2, right? Because this is the second person starting from 1. After that, I'll land at 3. So since I'm at 3, now which is the second person? So 3 is the first person, 1 is the second person. So I'll kill 1. So which person is left? Now there is only one person that is left that is not killed and that person will be given the freedom. So the safe position now is nothing but 3. So I can say that for this also the position is 3. Now if you will see, so this is a process. This is a particular process of killing. Like killing every kth person from a certain index I, let's say I'm killing every kth person. So this is a particular process that we are repeating. And when we talk about repeating something, then we can clearly observe that if we want to repeat something, if we are performing a task again and again, then which algorithm or which concept comes to your mind? The concept is nothing but recursion. That is when we are doing something again and again, then we can use recursion in that place. So you can understand that in this problem also we can use the recursion for doing the same task again and again. Killing like from starting like from every ith index, I'm killing k minus 1th person, right? From that ith index, I'm killing the k minus 1th person. So that again I can say that I'm using recursion here. Now let's discuss another case here. So suppose that we have been given another test case, that is, let's say n was given as 5 and we were given k is equal to 3. Now in this case, we have 1, we have 2, we have 3, then we have 4 and after that we have 5. So if you'll observe, so which like I'll start from 1, I'll kill every third person. So what will happen? I'll kill 3. Then after I've killed 3, so I'll stand at 4 because that is the next person. So after that, I'll kill every third person again. So 4 is the first person, 5 is the second person, 1 is the third person. Then I'll kill 1. Then I'll stand at 2. So now since I'm standing at 2, so what is the third person from 2? So 2 is the first person, 4 is the second person, 5 is the third person in the clockwise direction. So I'll kill 5 after that. Then what will happen? Again, I'll come back and I'll stand at 2. Now 2 is the first person, 4 is the second person, then again I move to 2. So now 2 will be the third person, right? Because 2 is the first, 4 is the second, then again I come back to this 2. So this 2 is what? This 2 is nothing but the third position. So I'll kill this guy. Now the person that is left is nothing but 4. So the position that is safe is 4 here. So you can see that I'm repeating the task again and again. That is where recursion concept will come into my mind. Now, when I think of recursion, so I have to think something more. Like how will I implement it? So I can think of using array. Like what I can initially do is, I can say that since n value, suppose that n value is given as 3 and suppose that k is equal to 2 here. So in that case, what I can do is I can declare an array in which I can have the index, like I can have the elements 1, 2 and 3 stored initially. Then what I can do is I can say that initially I'll be standing at the 0th index, I'll be starting from the 0th index, and which person I'm going to kill? I'm going to kill this person here. If k is equal to 2, then I'm going to kill this particular person. That is the second person. So basically I can say that if I'm standing at a particular index I, then which person am I going to kill? I'm going to kill, like which index I'm going to kill. So if you will observe, let's say if in fact if k was given as 3, suppose if k was given as 3 here. So in that case, which person I'm going to kill? I'm going to kill this particular person, that is starting from here, the first person, second person, third person. So 3 is the third person. That is what I'm going to kill here. So let's take n is equal to 5 in fact, so that things will be more clear. So in this case, let's say that n is given as 5 and k is given as 3. So I'll have the array as 1, 2, 3, 4 and 5. Now I am starting from this particular index, that is from 0th index, right? And I can say 0, 1, 2, 3, 4. That is, these are the indexes, and I'll kill every third person. So basically I'll kill this particular person. So initially I'll start my I from 0. Now which person I want to kill? I want to kill the person at the second index. So I can say that I want to kill which person? I want to kill the person at the index I plus k minus 1, because k value is what? Like I value currently is 0. 0 plus what? 3 minus 1 is nothing but 2. So basically I want to kill which person? I want to kill the person at the index 2, that is this particular person, right? So that's how I'm going to update my I. Now when I update my I, so what can I do? I can simply write an erase function to delete the element at this particular index. When I will erase this particular function, then what will happen? Now I can say that what will happen, I can basically say that now I will stand at 2. So when I will remove this particular element, then what will happen? The indexing will also change. Now what will happen? This will be the like 4 will stand at the index 2 and 5 will stand at the index 3, because one element here has been removed. After that, what I can say is now my I is standing here. Now what will happen? I need to kill again. So I need to kill what? I need to kill the again the kth person from here. So if I'll see, so I want to kill the third person. So the third person is what? I can say that 4 is the first person, then 5 and then 1. I want to kill this, right? But if you will observe, so I am doing what? I am saying that I is equal to nothing but I plus k minus 1. And if I do that, so currently I is standing at 2. 2 plus 2 will give me 4. Whereas you can see that actually the index 4 is not existing now in this array, because the array size is continuously reducing. So to keep this I on a check, what should I do? I should, like, my initial, I am saying that I want to kill this particular person that is at the 4th index, but actually the 4th index is not existing. So I want to actually kill 1, that is this particular person, because the third person starting from 4 is nothing but 1. So what can I do? In that case, I need to keep the I in the limit. So in that case, what I can do is I can simply say that I can do the modulo. So if I do the modulo of the I plus k, like in that case, what I can do is to keep I under control. What we can basically do here is we can say that I is equal to I plus k minus 1 modulo the size of the array. So array dot size modulo the current array size. So in that case, what will happen? 2 plus 2 minus 1, that will be 2. Okay, and then I'll take a modulo. So I'll take the modulo with the size of the array, so that will be 4. So 4 modulo 4 will give me what? It will give me 0. So now I will become what? I will become 0. So basically I'll kill this particular person, because now I is standing here, right? I gets updated here, so I'll kill this particular person. So in that case, this person will get killed and the indexing will change again, because the indexing will now be 0, 1 and 2 here. Now I is standing here. After this, what I can do is I can simply say that now I want to kill 5. So basically I can say that I is equal to 0 plus again k minus 1 is 2, and I will take the modulo with the size of the array. So what is the size of the array now? Size of the array is 3. So I will be equal to what? 2 modulo 3, that will be 2 only. So I want to kill this particular person. So after that, what will happen? I'll kill nothing but 5. So when I kill, after that, when I kill 5, so now I is equal to basically 2. So now what is happening? I is standing at 2. That is this particular imaginary index 2. Now I is standing at 2. Now which person do I want to kill? I if I will see, so basically now indirectly my I will be standing at, like I am standing at 2 now, because indirectly this index does not exist. So I want to do what now, since I'm standing at 2, so 2 is the first person, then 4 is the second person, then after that the third person will be 2 itself, so I'll kill 2. But how will I do this in terms of programming? So in this case, what will actually happen here is, again I'll update my I. So what will happen to I? Now I will be what? I will be currently I standing at 2, right? I standing at 2. So 2 plus, again k minus 1 is 2, and then I'll take the modulo with the size of the array, so that is 2. So now what will happen? I is equal to 4 modulo 2. So I will now become 4 modulo 2 is nothing but 0. So I will stand at 0. So again, wherever I is standing, I'll kill that particular person. So I'll kill this person up. When I kill this person up, so after this what happens? After this you can see that only one element is left, that is this particular element, and its index now will get updated to 0. And I can simply say that when the size of the array becomes 1, that is the base case when array has only one element. So I can simply say that I will return that particular element that is present at the index array of 0. So when array size becomes 1, then I can simply end this recursive call and I will return the element at the 0th index. That will be the safe position here. This is nothing but the safe position. Alright. Now let's quickly write the code for this particular approach. So what I'll be doing here is, I'll be given this particular function, that is n and k. N is nothing but the number of people initially, and k is the number of people that I'll be skipping, right? I want to kill every kth person. So in this, what I'll do is, first of all I'll declare a vector, right? So vector int array of size n, and after that what I'll do is I'll update this vector. So in this vector, I'll iterate. So for I starts from 0, I is lesser than n, and then I plus plus, I'll iterate through all the indexes, and I'll say that the first person, the element at the 0th index will be what? 1. So I will say that I plus 1, because if I'll observe, so if the people are like 1, 2, 3, 4, 5, so at the 0th index 1 is present, at the 1 index 2 is present, at the second and at the index I is equal to 2, the element is present at 3, at the index 3 the element present is 4. So basically whatever is the index, the element at that particular index is I plus 1. So I will initially store it. Once I have done this particular part, then what I'll do is I'm repeating the same process again and again, so I can use recursion. So in that case, I'll start my recursion from the 0th index, that is the very first element, that is the position 1 you can say, and then I'll pass k and I'll pass the array. Now in this particular recursive call, what I'll be doing here is, I'll say that this recursive call will be void in nature, it will not return me anything, it will help me to remove the element. So I'll say that int I is there, then k is there, and another thing that is there is the vector. So I'll pass the vector by reference here, so that any changes I make to it is reflected finally in the main function as well. Then what I'll do is I'll say that what is the base condition of this recursion, that if the array size after some deletion, if it becomes 1, in that case I can simply say that I'll return what? I'll simply return nothing but what? I'll simply return from this particular function, right? Other than this, what I'll do is, if I'm currently standing at the ith position, so I want to kill I plus k minus 1th guy. I want to kill the person that is standing at the I plus k minus 1th index, but I need to make sure that the updated index is coming inside the array. So that is why I'll take the modulo with the size of the array. Once I've done that, so what I'll do is I'll perform the erase operation. So I'll erase the element that is present at this particular new ith index. So I'll say that array.erase, like array.erase from this from the starting of the array, this ith index we will erase. Once I have performed the erase operation, then we can simply, since we are doing it again, like since we are recursively again and again deleting the people, so I can say that now I'll pass this I, I'll pass this k, and I'll pass this array, and the process will keep on repeating until only one element is left inside the array. And after this, when I return from this function, when only one element is present, so the safest position will be stored in the array of 0, because only one element will be left. So as you can consider that in this case only one element was left in the array, and the element left was nothing but 4. That was the safe position, and obviously if one element is there only, so the position will be 0. So I can say that array of 0 I'll return, that is the safe position here. So that is what I'm trying to return here. So let's try and compile this code to see if I've made any compilation errors or it works fine. So it works for the sample. Let's try and submit this code as well to see if it works for all the other cases as well or not. So you can clearly observe that my solution was able to pass all the test cases. Now talking about the time complexity of this particular approach. So the time complexity of this approach will be nothing but order of n square, because I'm iterating as well as deleting. So the deletion operation will also be considered. So in the worst case, the time complexity will be order of n square, and the space complexity for this approach will be order of n. If you understood this explanation, make sure to hit the like button, and comment down understood as well after you have watched this particular video. And if you have not subscribed the channel, that is Geeks for Geeks Practice, so you can subscribe this channel as well and share it with your friends as well. Thank you for watching this video. Have a nice day.